Hey, what's up? Let's do some math today. In this video, we're going to talk about operations with radicals. So when I'm talking about operations with radicals, we're going to be looking at two types of problems: addition and subtraction, and then multiplication. So we might be looking at something like square root of 3 plus the square root of 2, or we might be looking at the square root of 3 times the square root of 2. So it's important that we just kind of talk about some of the basics, and then we'll take a look at some examples so that way we can tackle these problems. So adding and subtracting, it's really simple. We just have to look for like terms. Look for like terms. There we go. And like terms are things that are under the radical that match up. So for example, square root of 3 and square root of 2, they're not like terms. And we can't combine those any further. But if we had square root of 3 and then let's say something like 5 square root of 3, those both have square roots of 3. They are like terms. So for like terms, we're looking for the same number under the radical. For multiplication, we have a simple word that goes with this: cohorts. When it comes to multiplying these, we look at what's inside and outside the square root, and what stays and there's very little intermingling between the two. So we're going to multiply the things that are outside of the square root by the other things that are outside the square root, and then we'll multiply the things that are in the square root by other things that are in the square roots. So we'll see some examples of that. But right now, let's look at some examples of adding and subtracting. Okay, so first example here is 6 square root 5 minus 3 square root 5. I notice that these both have the same radical, root 5. So these are like terms. And if that's the case, I'm doing finger math. I have 6 of something, and I'm taking away 3 of them. That leaves me with 3 square root 5. Box it, walk away. And that's as far as I can take it. Now, let's take a look at number 2. We have 8 root 7 plus 8 root 5. The 8s are the same, however, my radicals are not the same. So I can't do anything. Okay, this is no different than saying 8x plus 8y. I can't combine those. So my final answer is just going to be 8 square root 7 plus 8 square root 5. And that's as far as I can take it. Now, number 3 here has a bit of a tricky problem. It looks like we can't do anything with it yet. Now we need to use some of our simplifying skills. So for example, I know that 12 is 4 times 3. And I know that 75 is 25 times 3. What I have here are some perfect squares. And what's going to leave me with is 3 in the radical. So my 4 will come out as a 2, and I'll be multiplying that by the 3. So I will have 6 root, and then all that's left is 3, plus here there's an invisible phantom 1. The 25 will come out as a 5 and multiply to that 1 to give me 5 root 3. Now, taking a look at my numbers, the radicals are the same, so I can combine them. 6 plus 5 is 11 square root 3. And that's as far as I can take that one. Now, let's take a quick look at some multiplication problems. So there's a big idea I want to get across. Let's go a new color here. That is, the square root of x squared is equal to x. Or, another way to think about this is if we had the square root of x times the square root of x, that's just going to equal x. Those undo each other. Because remember, rooting, taking the square root of something, is halving with multiplication. We have 2 equal halves here, and so it just ends up equaling the one thing itself. Okay, now with that being said, we have to remember our key word, cohorts. Cohorts, is a word that we all got familiar with here recently. We have inside, or actually let's say outside and inside. The outside numbers in this first one are 5 and 4. Those will get multiplied together to give me 20, and then that's the outside number. Now I multiply the numbers on the inside, square root 6. I then check to see if I can simplify this number. Square root 6 can't be simplified, so that's as far as I take it. I multiply my numbers in cohorts. Now here we will be able to simplify something. But first, we apply the same logic. I take negative 10 times 2 to get negative 20, times the square root of 6 times 3 is 18. Now I can double check. 18 breaks down as 9 and 3. Oops, sorry, 9 and 2. 9 and 2. Let's cross that out. 2. The 9 will come out as a 3. Multiply by my negative 20, so I'll get negative 60 square root 2. Box that. Walk away. Number 3 here. This can be written out twice. 2 square root 7 times 2 square root 7. Again, my cohorts, outside, inside. 4, and then when I multiply my square root 7 together, that's going to give me square root 49, which is just 4 times 7, which is 28. Finally, let's take a look at this one right here. Again, cohort idea. 4 times 3 is 12. And then here, multiply these together to get the square root of 150. Now, this big number makes a good example for us. If I think of what I have in my my 10 and my 15, I have a common factor of 5. And so I'll have 12, still my outside number, but now I'm going to have 5 times 5, 1 from each of these, and this is 2 and 3. So 2 times 3. The 5s can come out as 1, leaving me with 60 square root 6. Now get that last one might be a little bit tricky, but maybe with a little more practice, it'll come more easily to you. So good luck on your practice, and let me know if you have any questions.